So the fourth method of factoring, or sorry, not fourth, second method of factoring we're going to talk about is called, any guesses? Grouping.
Oh, you guys.
Yeah, well, gee, how do you know that?
I think you were here yesterday.
Oh, that's right. All right, Jason.
We use grouping when you are given 4 terms. Okay, so when you go to factor, check to see how many terms there are. That'll tell you what method you're using. When you also go to factor, what must you remember to take out first? GCF. Always check and see, can I take out a GCF? That's your first step. And then once you check to see if you can take out GCF, then you're going to ask yourself, how many terms do I have? The amount of terms will tell you which method you're using. So if you have 4 terms, you're using grouping. Every time. Let's take a look at an example. To factor by grouping, you're going to do exactly how it sounds. You're going to group the first 2 together. And before we do that, can we take out GCF? Their number then go to 3, 2, 9, and 6. All 4. Yeah, so they're always on GCF. If the GCF is 1, there's not 1. And then none of them, or sorry, all of them have a variable but 6, so that we can't take it out. They all have to have at least 1. 6 does not have a variable, so there's no GCF there. So you group the first 2 and group the back 2 together. So then, do exactly what we did yesterday. You're going to take out the GCF between the first group. So between 3 and 2, can we take a number out? Is there a number that can go into both besides 1? So then look at your variables. Between x cubed and x squared, what are we going to take out? X what? Squared. Good. Always just look at the exponents. This one has a 3, that one has a 2. The smaller one is 2, so we're going to take out an x squared. Then write your leftovers. We didn't take any numbers out, so our numbers are going to stay the same. But we had 3 x's and we took 2 out, so how many are going to be left? Plus, we didn't take any numbers out, so that's going to stay a 2. We had 2 x's, took 2 out, so are any left? Whatever sign is in the middle, here in between our 2 groups, there's a plus sign. You're going to drop down that plus sign. Then you repeat the process. You're going to take out the GCF between the back 2. What's the GCF between 9 and 6? 3. Can we take out a variable? No. They both don't have an x. The only thing we take out is 3. And what are our leftovers going to be? 9 divided by 3 is? You can take out an x, so that's there. 6 divided by 3 is? 2. What do you notice about those parentheses? They're the same, and they're always going to be the same. So if you don't get the same parentheses, something went wrong. Either you probably more than likely took out the wrong GCF. Usually is what happens. All right, so go back and check your work if that happens. But they're always going to be the same no matter what. Yes?
Can't we skip ahead and just once you find the first number inside the parentheses, just put
Yep. Yep, that's our shortcut. Once you know, because now that we know they're going to be the same, whatever this ends up being, that you just go ahead and write that. So now make your 2 parentheses to fill in your parentheses. You notice both of these terms have an x plus, 3x plus 2, so that's kind of acting as our GCF. And we're going to take that out. How I like to think of it is the repeating parenthesis, you just write once. And then the GCFs, you're going to write in the other. And you're done. Same exact steps every single time. You'll just be dealing with different numbers. But the process is exactly the same.
It's not bad. You're looking at it saying, there's a lot of stuff going on here. But it's not that bad. Really what you're doing is you're doing 2 GCF problems. And then you're putting them together at the very end. That's it. That's all it is. So let's look at number 2. How many terms are there? How many groups of numbers and variables are there? How many? I'll be up here originally right now.
You don't need to-
4. 1, 2, 3, 4. Whenever you see this, because some people ask, well, how do I know to do GCF? How do I do to do what is lead coefficient? How do I know to do grouping, split the middle? How do I know to do that? If you see one that has 4, odds are you're going to be factored by grouping. We should always check to see if a GCF goes into all of them first. Sometimes do, not very often. Is there a number that goes into 4, 8, 5, and 10? No, there's not a number. So this is where we are going to group it, 2 by 2. Group there. Group here. Group those two guys. All right, and then we're going to do 2 GCF problems. I'll do the one, the red over here on the left, and I'll do the purple one on the right. So we need to find a GCF. I'm just going to look at the numbers first. I need to find a GCF between 4 and 8. What is the greatest common factor between 4 and 8? 4 is, I agree. 4 is. So there's 4. Do they share a variable? They have a common variable between the 4 and the 8? Yeah, they have x's. And which one is the smallest? You guys said it. X squared. I'm trying to take as many as I can out. Some of you guys yesterday in your GCF practice, you say, yeah, they share an x, you take 1 x out. Well, there's more x's I can take out. The most I can take out is x squared. So that will be my GCF. X squared, and I'm going to start up my parentheses. I know I'm going to divide by 4x squared. That's an x, by the way. I'm going to divide by 4x squared over here. Leftovers drop right down. 4 divided by 4. Or what happens to these 4s? They cancel out. What is x cubed over x squared? X. They have 3 up top, 1 down low. There's just 1 left over. Whatever the sign is drops down. 8 divided by 4. 2. And we know x squared will cancel out. So that's what we're left with. Great. Now, let's do the purple side, the GCF. Whatever that sign is, you notice when you have a one with 4 terms, there's always going to be 3 signs separating them. Whatever that middle sign is going to drop down. In this case, it's a positive. So put a positive there. We've got to figure out what number it is. Well, what's the GCF between 5 and 10? 5 is, I agree. It's going to be a positive 5. Do they share an x? No, 10 doesn't have an x, so we know it's going to be there. So we should divide by 5 as well over here, but we already know it's going to be in that parenthesis. What's going to be in that parenthesis? X minus 2. They should be the same. Just double check ourselves. 5 divided by 5, those 5's cancel out. X drops down. It's a negative. It's a negative. 10 divided by 5 is 2. It's good. Here's another helpful hint for you guys. Some of you guys say, man, Star, Baker, I am not good at numbers. All right, some of you guys have a hard time recognizing GCFs. I get it. You say, man, I can't figure out what this GCF is between 5 and 10. Now, you guys know, I realize. So, based on the idea that we know these two parentheses need to be identical, all I have to do is say, all right, this somehow turns into that because they're the same. So all I have to say is this. X times what gives you 5x? X times what gives you 5x? 5. Guess what? There's your GCF. It always works. 3 times what gives you 9? Found it. That always works. So you say, how do I turn this into that? Well, I multiply by 5. 5 times x is 5x. 5 times 2 is 10. Found it. There's my GCF. One last step. I need to put them together. I like to say this. The duplicates. Which ones are the same? Some people say you want to put x squared. Don't put x squared. We're just writing it one time. It's like a pair. It's like a buddy's coming out. So x minus 2 is my duplicate. And now I have the leftovers. What the dudes are left over? So it's going to be 4x squared plus 5. Now, some of you are asking this, well, does the order matter here? No. You can write either way. If you like to have the leftovers first, go for it. So you can say 4x squared plus 5, and then x minus 2. Either one of those is acceptable. Why? Well, what's 3 times 2? What's 3 times 2? 6. What's 2 times 3? Yeah, doesn't matter the order of multiplication. So if you write it either way, it's fine. Yes, you.
We're gonna have to change it to like.
You're saying bring it back to the 4 terms?
Or we have to do that.
You don't have to, no. If you want to do that, you just coil it back together. That's a great way of checking to see if you did it right, but we're just factoring it out, so we're breaking it down to its bare minimum there. Yes, you. That doesn't matter. What you're saying, this is negative and positive?
Yeah.
That's just going to be based on what signs you have in here. But I do know that these need to be identical. You'll see a case where one of these, if you don't do it correctly, one will be negative, one will be positive. So we'll try to fix that. So yes, it doesn't, down to your final answer, one doesn't have to be negative, one doesn't, they'll change based on the problem you have. We'll do more.
They both have to be the same.
These two have to be the same. When I break it down, those leftovers you're thinking about need to be identical.
Okay.
So if you got to a problem where one's negative, one's positive, you made a mistake, and I'll show you what that is. You'll see it probably on this guy. You'll see that scenario.
Okay. Again, always check that we take out a GCF. No. No, have a variable, not have a number, so you can't take out a GCF. So then go ahead and group. Group your first two. And group your second two. And then GCF your groups. What's our GCF between x cubed and 2x squared? X squared. They both don't have a number, so you can't take out a number. You can take out the variable x squared. So we write our leftovers. We had 3 x's, took 2 out. 1 is left. And then take out a number, so that stays a 2. Had 2 x's, took 1 out. Or sorry, 2 out, so none are left. Again, whatever that middle sign is, you're always just dropping it down. And then what's the GCF between 3 and 6? 3. What do our leftovers have to be? What do our leftovers have to be? X plus 2. Some of you might be thinking, well, why is it not x minus 2? Because there's that minus sign there. The reason is, because we dropped down that negative, our GCF is now technically negative. And whenever you have a negative GCF, it always flips your signs. So that negative in the middle now becomes a positive. That's why that works. Just recognize the pattern. Drop down the negative, take out your GCF, and then these have to be the same. Okay? So that's why the sign flips. Because your GCF is technically negative. When you have a negative GCF, it always changes your signs to the opposite. Right, your parentheses, what's going to go in one parenthesis? X plus 2. What's going to go in that second parenthesis?
Number 4. Moving along. Alright, I got number 4 up here on the board. Ooh. 5 goes into all these numbers, doesn't it? Does 5 go to all 4 of these terms? Silly 18. 18 won't allow that. They don't allow the variable. So we have 4 terms. We know it's going to be grouping. So I'll group that guy. Group that guy. Let's figure out what we got. So, 15 and 25. Just look at the numbers. 15 and 25. What's the GCF between 15 and 25? 5. I agree. So I'm going to put a 5 over here. Oh. I'm going to put a 5 over here. We don't have those colors. Do they share a variable? What is that variable? What did you say? X squared. They both have x's. The smallest one is x squared. Take out as much as you can. We know that's all we can take out. I'm going to divide each by 5x squared. 5x squared. 15 divided by 5. 3. X cubed over x squared. The sign's negative, drop her down. 25 divided by 5. 5. And we know x squared over x squared will, in fact, cancel out. So just using that little helpful trick. We know that this middle sign is negative. That will fall down and make this negative. Do you guys know off the top of your head what the GCF of 18 and 30 is? You may. Or do this. Here's a little question. 3 times what gives you 18? 6. Do they both share an x? No. If that 30 had x, I would take out a 6x, but it doesn't. So that means I can start my parenthesis. Do I know what's going to be inside that parenthesis? Yes, Mr. Carr. Oh, thank you, class, for volunteering that answer. What is that answer that's going to be in that parenthesis? 3x minus 5. And again, the reason doing this is it kind of eliminates. Yes, you really should do the minus 6 or divide by negative 6. Negative or negative is a positive. Positive or negative is negative. But sometimes if you don't remember to take that middle sign, that's what changed your answer. Get 2 different parentheses. We want these to be identical. So as long as you drop that sign down that's in the middle, and then do the little trick, multiply what it is, and just put that positive there, it's going to make it right. So if these are not identical, you did something incorrect. Last thing I need to do, copy the duplicates. 3x minus 5. And then the leftovers. 5x squared minus 6. Questions with those? Okay. You know what comes after 4? 6. Go back to home.
Again, with number 5, always check and see, can we take out a GCF between all 4 terms? No. So go ahead, you have 4 terms, we're going to group. Group the first 2, group the back 2. What's our GCF between 10 and 15? 5. And what are you going to take out between x cubed and x squared? When we write our leftovers, 10 divided by 5 is 2. Had 3 x's, took 2 out. 1 is left. Plus 15 divided by 5 is, had 2 x's, took 2 out. None are going to be left. Again, remember, whatever that middle sign is in between your groups, drop that straight down. And then what's our GCF between 2x and 3? It's the only number that can go in the both. 1. And can we take out an x? No. So when this happens, make sure you still write that 1 there. So there has to be a placeholder, there has to be a number there. So in this case, this is where we can write that 1. And then what our leftovers have to be? 2x plus 3. Again, the reason why this sign flips is because this GCF is negative. So flip your signs. Parentheses. What's going to go in the first parenthesis? 2x plus 3. What's going to go in that back parenthesis? Perfect. 5x squared minus 1.
So I guys get the hang of it. You're saying, man, this is easy. You're talking about we get tested over this stuff? Yeah, you will. Man, I'm going to ace that test. That's just you guys talking to yourselves right there. Pretty good impersonation I did of you guys. I'm great at that. So, number 6. Is there a number that goes in 3, 2, 21, 14? So one number other than 1. I don't care about 1. Is there a number that goes in all those? No. No is the correct answer. So let's go ahead. Let's group up 4 terms. We know we're going to group. A little Barney colors right now. So between 3 and 2, is there a GCF? 3 and 2, is there a GCF? We know 1 is, but we don't really count 1. So that means we got to look at the variables. Do they have a common variable? It's an x. You're right, they do. What is the smallest of those x's? X squared. So that will be my GCF. X squared. I have an x squared. X squared. There we go. Well, notice there's nothing affecting that 3. There's nothing dividing with the 3. So 3 will drop down. X cubed over x squared. X. The sign is positive. It is positive. Nothing affecting the 2 in the other one, so it's just a 2. And we know x squared over x squared, that cancels out. X2 over they subtract. It'd be 0. All right. Always, always, always remember to drop down that middle sign. Once you're done with that first GCF type part of it, drop down that sign. It's a negative. Negative 2. What's the GCF between 21 and 14? I don't know. All right, if you don't remember, 3 times what gives you 21? Found it. They both don't share an x, so it's just going to be 7. Start on my parentheses. What's going to be in the parentheses? Done. Last step, and some of you still forget the step, and sometimes make errors, just careless errors. Copy the duplicates. Duplicate of 3x plus 2. Copy the leftovers, things outside. X squared minus 7. How about that? You guys that already have not moved on, feel good about this. All right.